All right, here we have a graph of f prime, and then they're asking us a bunch of stuff there. So part A says, do you have a relative max, relative min, or neither at x equals 6? Now, to make something a maximum or minimum, the graph of the derivative must change from above to below or below to above. That means from positive to negative or negative to positive y values right there. But at x equals 6, the derivative does not change from above to below or below to above. It stays above the x-axis, which means your derivative graph stays positive. So that's why I got neither, since the f prime doesn't change sign at x equals 6. At x equals -1, you're talking a maximum on f because your derivative changed from above to below, from positive to negative. X equals 2, you're talking a relative min on f because your derivative changes from negative to positive, from below to above there. All right, so neither on part A, since the f prime doesn't change sign at x equals 6. Part B says, is the graph of f concave? What intervals is the graph of f concave down? So I try to talk myself into the right answer here. So I know f is concave down where the second derivative is negative. Now to get from the f prime to the f double prime, we take a derivative, which is slope. So when I ask myself, where is the second derivative negative? That's the same thing as me asking myself, where is the slope of the f prime graph? Negative. Where is the slope of the given f prime graph? Negative. So where the slope is negative, that's where this f prime graph is decreasing. So your f prime graph has a negative slope, and that means the f prime graph is decreasing from 0 to 2 and then from 4 to 6. So you need the intervals, and you really need this for your justification. That's where your f prime graph is decreasing right there. All right, letter C. Let's be really careful with how we write the notation for letter C. The AP graders, they are really picky about this L'Hopital's rule thing right there, okay? So they really want us to show, we're just going to plug into the top and the bottom like normal to see if it's 0 over 0 or infinity over infinity, but they really want you to show the limit of the top equals something and the limit of the bottom equals something. And then you can mention that's in the indeterminate form of 0 over 0. They don't want you to just say, hey, it's equal to 0 over 0. They really want you to show what the limit of the top and the bottom are equal to. And then we could do our L'Hopital's rule and do our thing with that. So when I'm doing the limit of the top and the limit of the bottom, I am just taking the 2 and plugging that in right there. They tell us that f of 2 is equal to 1. So that gives us 6 times 1 minus, take the 2 and plug that in for that x as well. So you get 6 minus 6, which is 0 up top. And when you plug in the 2 on the bottom, you get 4 minus 10, which is -6 plus 6, which is 0 on the bottom. But just do me a favor. They really stress this at the conference, AP conferences that I go to. Just you're plugging it into the top and bottom. Just put the limit as x approaches 2. Put the limit of that equals 0. Put the limit of the bottom part equals 0. And then we're good. All right. Then, since you do have the indeterminate form of 0 over 0, now you can apply L'Hopital's rule. So I'll do limit as x approaches 2, and I'll take the derivative of each piece here. So I'll do 6 times f prime minus 3, and I'll do 2x minus 5. And then I'm going to take the 2 and plug that in. Now, when you do f prime of 2, f prime of 2 is f prime of 2. This is your derivative graph. That just means at x equals 2, what is your y value equal to? So f prime of 2 is equal to 0. So that's why I'm getting this -3. And then I just took the 2 and plugged it in for that x right there. So we got that -3 over -1. So a +3 for that answer there. All right, now we know the deal on the absolute extrema problem. Okay, so on an absolute extrema problem, we're going to make a normal XY chart, and we're going to check the endpoints of the interval and also any critical numbers. So I'm doing a normal XY chart for x and f of x. The -2 and 8 are on or automatically. Now, since I'm finding an absolute minimum, I'm looking at this graph. I could include -1, but I know at -1, the derivative changes from above to below, from plus to minus. So that means that's going to be a maximum. So I don't really need to check that one. If you did check it, it's okay. It's not the end of the world. It's not going to be the absolute minimum value that they're looking for. But here, this at x equals 2, the derivative has a relative min, and then we need to check that number to see if it's also an absolute min. And so if your derivative changes from negative to positive, that's a minimum value, and that's what you're looking for as a minimum value. So that needs to be on your actual chart there. So these could occur at the endpoints or those critical numbers right there. Technically, the critical numbers is where that derivative is 0 there at -1 and 6, but we already said 6 was neither from part A, and we said -1 is a maximum. So if you're doing a relative min, you only really need to check those 3 values right there. Now, they told us f of 2, this is the y the y row, the y column, that's the f of x. So they told us f of 2 is equal to 1. So we already know that from that given piece of information right there. So you need to figure out what the at -2 and 8 is. So there's two different ways that you can kind of figure out what these numbers are. One way is to get from f prime to f of x, we need to integrate that. So I'm going to integrate that. I got to use this -2 because that's what we're trying to figure out. And I'm going to use this 2 because that's what we're given. So I'm going to integrate from the -2 to the +2 of that f prime. When I integrate f prime, I get f of x, and I can do my top minus bottom, like for our definite integral right here. Just you need a number for this integral, and then you can solve it for that f of 2, which is what or the f of -2, which is what we want right there. So the number one representation of your integral is an area. So I need the area of that given graph between -2 and +2. So in between -2 and +2, so you're talking this triangle piece right here, which is positive, and then the +2, you're talking this piece right here, which is negative. So you kind of see my work I did, 1/2 base times height minus 1/2 base times height, because that one went below the x-axis, so it was negative. So you kind of see my geometry work right there to to get the to get that area is a -2. That's what that integral is equal to, a -2. And then you solve that for f of -2 to get that +3 number. So see all my work right there. All right, and then same deal with f of 8. So I need to use the 8 because that's what we're trying to figure out. And I'm going to use the 2 because that's what we're given. So I'm going to integrate f prime between 2 and 8. That gives me f of x, plug in top minus bottom. And now I need the area between 2 and 8. So between 2 and 8, it's the area between the curve and the x-axis right there. So in between like 2 and 4, I had like a little triangle piece right there. So I did 1/2 base times height for that piece of it. And then I would need the rest of it between 4 and 8. I need this little sliver here and this little sliver right here. So what I did a rectangle. I did this whole rectangle and I subtracted out that semicircle, and that gave me what was left over right there. So there's my rectangle, and there me subtracting out that semicircle there. So make sure you force your brain to kind of go through those steps. No calculator. Make sure you kind of force your brain to go through those steps and get those correct numbers. And then that gave me that integral was that 10 minus 2 pi. And then I carried that down. I wanted to solve for f of 8. So f of 2, they told us, was equal to 1. So just move that 1 over, and then you get this 11 minus 2 pi. Now, when you're trying to figure out the absolute min, estimate that pi is about 3.14 or somewhat close to 3. So you're really doing 11 minus 6 something, which is going to be like 4 something. And so that's still bigger than this 1. This is the smallest y value right there. So remember, if they say, where's the maximum occur at, they want the x5. But if it says, what is the value or find the minimum value, they want to know that y value right there of 1. And then there's another way that you could figure out these couple of numbers right here. If you kind of look at my work and see if you want to try and do that approach, like if you do f of 8, that's the given f of 2, and then you can pick it up where you left off and then integrate it from 8 and kind of get that 11 minus 2 pi that way. If you want to do f of -2, start with your given and then pick it up where you left off, go to where you want to go. And then since those are reversed, you would switch the sign right there, and then you're still involved in the areas. And just remember, the integral will be negative if that curve goes below the x-axis right there. So let's just kind of practice that, especially if you're pretty good with those. Make sure you shore up that notation. Make sure you really practice those absolute extrema problems there, because that could be something that the rest of the nation struggles with. And if we keep working at that, we're going to get really good with those. Tater tots. Taters